Let's think about this. Let's design an aircraft electrical system of a very simple form. We just have a DC bus. So this is our DC bus. And that will be supplied by, let's say, a battery on this side. I would run a few consumers. So we use our typical circuit breaker, and we have a lamp again as a consumer, and another circuit breaker, and some mystical box here which contains some instrument. Alright, now the whole system runs for a certain while. That is exactly as long as the battery lasts. So we need something to charge the battery, and we can go and use engine power, for instance. Drive an alternator, put a rectifier at the back of it, and supply the system. Now, as a footnote, we have an alternator with a built-in rectifier. We call this generator. And in fact, every generator has an alternator inside, even though you cannot see the alternating current. And do you remember the numbers? Yes, the voltage in a DC system in an aircraft is 28 volt DC. Now we can recharge the battery as long as the engine is running. Of course, we are not immune against any form of malfunction, so our generator may simply cease operation, our cable may break, our mechanical linkage to the engine may break, anything goes wrong. No problem, we still have the battery supplying the system. Now there's a little problem with the battery, because it cannot last for extremely long, for very long. As we know, operating a notebook every day, as we know, operating a handphone every day, there is a limited time, there's a limited capacity. We want to recharge again. Now we need another source of energy. Well, one could argue we could have another battery, or one could argue we could have another generator. Why not? So let's build the same system with another battery. So I have this battery here. Now would I connect this battery to the same bus? I could, but maybe I shouldn't, because in our good old philosophy of redundancy, I better have things double, triple, or even more. So now, instead of supplying the same old DC bus with my second battery, I simply generate another DC bus. Now I give it numbers: DC bus 1, DC bus 2. This becomes obviously my battery 2, while this is my battery 1. And if you look for it, 1 is on the left hand side, 2 is on the right hand side. Generator 1. And I could have a generator 2 on this side as well. Then I could have other consumers here. Let's say the co-pilot's reading light. Oops, there's a mistake. We need a protecting device. And there could be the co-pilot's instrumentation. Oh, here as well, need a protecting device. Yeah? So, now we still have the problem that, for instance, my generator 1 can fail, my battery 1 can fail, something can fail. I have redundancy. I have my battery 2. I have my generator 2, but it doesn't help powering the captain's reading light. I have to link the two together. And this is simply done with a bus tie. Tie the same way we tie our shoelaces, then we tie the two buses, like this. So that would be our bus tie. Now that doesn't look so smart, because if we lose our bus 1, then this one would cause a loss of bus 2 as well, total darkness. So short circuit on bus 1 would cause a short circuit on bus 2 as well. So bus tie shouldn't be a constant connection, but maybe it should offer us control, switching. And switching is the secret to it. We put a little switch in here. That's the wrong one. Let's stick with yellow. We put a switch in here and call this the bus tie switch. Now in modern aircraft like the Airbus, we don't want to switch around anymore. We leave this function to some magic box, and that would be the bus tie control unit, or a bus power control unit, or whatever designation has been found by the manufacturer. And that's the way it works.